back, and here we are with another lesson within trigonometry. So, before we begin, I'd like for you to pause the video right now and find the area of this triangle. You're like, Mr. Beal, that is so incredibly easy. Good. Go ahead and pause the video and find the area of this triangle right now. Okay, so how would you do? You're thinking, yes, 1/2 length times width, or 1/2 space times height. So 1/2 times 20 is 6 times 13, so when you evaluate that, you get 169. And of course, we have our units, because we cannot forget our units. Easy, right? I mean, I probably did that in middle school, maybe elementary school. Well, if you're confident with that, find me the area of this. So we have 20 millimeters. You have 20 millimeters and 120 degrees. So if you could, pause the video and find the area for this figure. So how'd you do? Did you figure it out? Did you recognize that this formula, 1/2 times length times width, is only applicable for a right triangle? Or did you try to use it here? Did you try to take 1/2 times 20 times 20 and just disregard the 120 degrees? So this formula is in fact specialized for right triangles. Okay, so with what we know so far, we do not know how to find the area of triangles situated like this, with obtuse, or even if this was an acute angle. If it wasn't a right angle, we would not be able to use 1/2 times length times width. So in this lesson, we're focusing on what is called the sine rule for area. So it has us focusing on how to find area when we do not have a right triangle. And this rule will work for a right triangle. It will, which is great because we could just use this formula instead of 1/2 times length times width. So we have a triangle ABC. We do not know if it's a right triangle. We do not know if it's obtuse or acute. It doesn't matter. So we have angle A, length B, length C. So the formula reads as this. Area equals, I have my area here, not angle A, it's area. Area equals 1/2 times, let's say A times B. You're like, that looks a lot like 1/2 times length times width. Sure. So 1/2 times A times B multiplied by sine of the angle between them. And that is what's new, hence the sine rule. So 1/2 times A times B times the sine of the angle between them. So this must be the included side, or the between, or let me put it this way, it must be between two known sides. Okay, so that's it. For any triangle, to find the area of it when it's not a right triangle, I take 1/2 times 2 lengths, and I multiply that value by the sine of the angle between the two lengths. Okay, this is the sine rule. With that being said, the needed configuration so one downside to this, I'm saying you can use it to replace the other formula. The needed configuration here is that you have to have a side angle side situation. So you have to have the two side lengths and the angle between them in order to use this. So let's take a shot at this problem. So we have an obtuse triangle, length 10, length 14, angle measure of 115 degrees. So take a shot at using our new sine rule. So 1/2 times two side lengths multiplied by sine of the angle between them. So utilize this real quick, pause the video now, and find the area. All right, did you get the answer? So we set it up, 1/2 times our 2 side lengths multiplied by sine of the angle between them. So placing this into our graphing calculator, we get, see if I can get the screen brighter for you guys. Hey, there we go. Okay, so we get 0.5 times 14 multiplied by 10 multiplied by sine of the angle between them. I check, am I in degree? I am, so I hit enter, 63.4415 centimeters squared. And it is that easy. Let's look at another example. So what if we have this one? So 2 angle measures, and I guess we need a third side length, don't we? That'd be nice. So you have 12 feet. You're probably wondering, Mr. Beal, you made a mistake. Aren't we supposed to have side angle side configuration? Yeah. We have angle side angle, don't we? That could present an issue. Or if I could just find another side length, then I would have what I need. Yeah, that's the point. So let's say we want to find this side length, or you can find this side length. Same process. So we're going to use law of sine to find this side length. Well, for the law of sine, I need my third angle to match with the 12. And when you work to get the third angle, you find that it is 81 degrees, I believe. Yes, it is. So we have sine of 81 degrees divided by 12 equals, now here I have options. I could find the left side length or the right side length. All that differs is which angle I use. So I'm going to use 54, which means I'm going to find the right side length, which is what I want. Okay. So when you cross multiply this law of sine, this nice proportion, you get a length of 9.8292 feet. All right, so that gives us this side length. I'm going to kind of highlight this a little bit. Now, we have this side length. So now I can set up law of the sine rule. So I would say the area for this triangle equals 1/2 multiplied by the 2 side lengths. Okay, now I have to recognize which angle is between the 2 side lengths, and that's where it would differ. If you used 45 in here to find the left angle, then you would have a different angle in the formula. So I used 45 to get the right length, but the 45 degrees is between the 2 lengths. Okay, the angle has to be between the 2 lengths. So setting that up and placing this in, we should get a value, let's see, of 0.5 times 12 times 9.8292 times sine of 45 degrees. We get approximately 41.7018. That's what's our units, feet squared. And there we go. Again, I want to make a note here before moving on. We had to use the included angle. So do not make the mistake of using the same angle you used for law of sine that was used to find a side length. Okay, do not make that mistake, please. And last, so this is kind of an extension off of the sine rule. Let's find the area of a regular polygon. Area of regular polygons were not in geometry. Technically, we kind of are. So a regular polygon, what this means to us, if a polygon's regular, that means that the side lengths are all congruent to each other, and the angle measures are all congruent to each other. So if I desire the area of this figure, so let's say we have a regular pentagon. Okay, so pentagon is 5 sides. So do my best to not make a mistake on this. Okay. It's looking good so far, It's not bad, not bad. Okay, so what a radius is good to know. A radius is from the center of the polygon to a vertex. So we're told that this radius is 8 millimeters. What's interesting about this is, think of it like a radius of a circle. That radius is the same the whole way around. Now, we want to find the area of this pentagon. Well, what did I just cut the pentagon into? What, 5 triangles, right? Where we know 2 sides on each triangle, 8 and 8. So I'm going to let you think about this to end the video. All we would need to find is this angle measure. We would need to find this angle measure, and knowing this angle measure, we could find the area of one triangle, and knowing that there are 5, we could multiply it by 5. So you should find that the area for this pentagon, I'm doing like a little subtext here, area of a pentagon, because you'll have to find the area of one triangle first. So the area of the pentagon is approximately 152.1690 millimeters squared. Okay, so best of luck to you working on this more, thinking about it more. The trick is knowing how to find this angle measure. And something to help you with that is what must all of these 5 angle measures have to add to. So that can help you find the value here. So good luck. We now have a rule, a way of finding area for triangles that are not right triangles. And it does have a limitation with sine equals side. And we're going to work with that more and look at other configurations and other formulas for it. So best of luck practicing this, and I'll see you in the next video.